of the not the fucking umpire, the whatever the guy's called, a whistle.
Ref.
The referee, yeah. It's down to the referee's discretion, so it's not set in stone. So he can be walking around the pitch and like thinking, "Oh yeah, it's about time now," and blow the whistle. So there's been skepticism in the past where he's blown the whistle deliberately just before like a goal has gone in or something, or just as a penalty's been given, and no one could do anything about it.
Even worse. Like, I can almost understand soccer. Like, I can understand what's happening. Like, rugby, I literally have no idea what's going on.
Rugby looks awesome, though.
At any time. Time.
Rugby is freaking brilliant.
Yeah, it looks amazing.
I don't follow it. I don't know all the rules about it. I don't watch it either. But I have so much more respect for rugby than I do football.
Rugby looks awesome. I just wish I understood it. I got stuck watching I got stuck in a loop watching like this rugby.
Yes.
Oh, hey, look,
that was the shot we're looking for, buddy.
Hey now.
What am I doing?
Every audio's after dark.
Hey now.
How do I go live? Let's see. Bang.
Here we go.
Is he gonna do a focus? There we go.
We need a close up of his crotch. I mean the amp. There we
go.
Man, what the fuck show am I?
What is that? What is that you're touching and doing?
Wouldn't you like to know, my friend?
I do. I would actually. That's why I asked.
Is that?
Yeah. So basically, what I'm doing at the moment is I'm putting the driver back. So this amplifier, this Taramps it's two amplifiers on the same board, right? A full bridge amplifier is essentially two amplifiers on one board, one down this side and one down this side. And all it is the audio is sent into this chip from basically the audio is sent into this chip after it's been modified by your preamp or whatever. And this chip then drives MOSFETs. So the Taramps 8K has 4 MOSFETs per side. So each side of the amplifier can do 4,000 watts RMS. And so, yeah, this is 4 FETs doing 4K. So at the moment, I'm just putting the drive chip back on, and we can see if we can get this thing running on the scope for you guys, so we can see exactly how these things create a sine wave.
Oh boy, he's multitasking right now, cuz.
Man,
look at that.
You know how I run this shit.
That's right. That's how we do things.
I might have to clip that for like an intro.
I know, right?
You know how we run this shit.
Diaguardo is like dying to get in here. He wants to argue with you, probably.
But we're live. Everyday Audios, number 54. Skipper one here.
Everyday Audios, Amplifier.
Yeah, Amplifier. Skipper one here. That's Taylor Fade.
Hey, how you doing?
And that's Mr. BareVids. Sam Vennard?
Vennard.
Oh, fucking hell, you said it right. Jesus.
Yeah.
Awesome.
Oh,
Thank
which
you
one?
very much.
Who's, me or Fade?
Which one?
Actually, I heard all of it right. I didn't hear anything wrong. So.
All right, good. We're both right.
Yeah, it's Vennard.
Ooh. No, I think that was me, Fade.
Dude, I'm like multicultural. I swear.
Yeah,
I legit know everything.
Mr. Bear Videos on YouTube. He makes stuff about grizzlies, brown, polar. I like the polar bear segment you do, the playlist you had.
Wait, is that a thing?
Yeah, BareVids.
It's the wrong spelling of bear.
Fade, like, give me a chuckle, Fade. Don't make me strike out like by myself, dude.
So, do you guys know where BareVids originated from? Why it is BareVids?
No, sir.
I think I did it on the 12-volt one, but you guys want to watch that?
Nobody watches it.
Nobody watches
it. I don't think people are aware that show still exists.
Yeah, no.
Are they still?
So you'll be surprised to know that the word bear, spelled B-A-R-E, in the UK, London specifically, it is a slang term for many. So if you want to say I have many chips with my lunch, then you could say man's got bare chips in it.
Shut the hell up! Are you serious?
Love it.
I'm serious. So bear is slang for many or lots of. Like I got bear hose, I got bear galdem.
Yeah, you got bear hose.
I got bear amplifiers to repair. So essentially, when I made the YouTube channel, which was in 2006, I was a 13-year-old kid, and wow. I created the YouTube channel back when YouTube wasn't known as a video sharing website. My mate said I took some videos in the playground right at school on my fucking 280p camera or whatever it was back then, and I wanted somewhere to send them to my mates on MSN, and my friend said, "Oh, hey, check this website out. It's called YouTube. Don't tell anyone about it, but you can put videos on it like for free." And I was like, "Sweet." And so I created an account, and I thought, I've got BareVids to upload, so I'll just call it BareVids.
That is hilarious.
I have wanted to change it many times in the past, but I guess now it's kind of stuck. And I guess because it's not a slang in America, I don't get the piss taken out of me for calling it like BareVids. But
that's another slang that means a lot different thing in America.
Well, bear.
Piss. No, taking a piss or whatever.
However y'all use. Taking the piss, taking the mick, taking the mickey.
All that. Yeah. Hot gang, total.
Yeah, but also I find in America, because obviously it's so freaking huge. So your states are the equivalent of different countries, like in Europe. Everything's so different. So you guys will have different slangs, like up and down the whole of the states, and different colloquials and stuff. So
the South has the best slangs, just so everybody's 100%. Clear on that.
What counts as the South? Does like Oklahoma and Texas count as the South?
No, everything's south of I-20.
Yeah. Like Louisiana, that's just it. Yeah, Louisiana and a little bit of Florida.
Maybe Florida, a little bit of
Florida. There was some funny language floating around when I went down to visit DD with Chan and Jassa.
I don't understand how Oklahoma considers themselves the South. Like, it cracks me up. Yes. You like to see homos naked, man. On the way, make it.
People still watch that movie?
Well, yes, like the greatest movie ever made about American football.
Yeah. So BareVids, 2006.
2006.
So you were making audio videos back then?
No. He just said he was on the playground.
I don't listen to nobody.
I was uploading bullshit videos from the freaking playground of my mates making stupid noises and doing horse impressions and whatever else kids do.
Is that still on the page?
Yeah, basically everything. Every single video that I've ever made is still on BareVids account. Whether it's public or not, I can't remember. I went ahead and unlisted a bunch of stuff. But I think the first ever speaker related video that's on there was I had this flicking cheap ass Walmart style computer speakers 2.1 system, which was like a 2.5-inch woofer, and it made loads of farting noises. I think it rolled off at about 90 hertz.
Sure.
And
that's not bad.
I was like, yeah, man, this is cool. So I was like filming my little PC cupboard shaking and shit with that. But obviously YouTube was like, it wasn't like well known at all. So there was like a little audio sort of community on there. A bunch of kids that probably weren't too social. Probably just like listening to their speakers in their bedroom as I was. And we were all just like sharing videos of and it was generally Logitech systems like Logitech Z4, the 2300Z, the 5500Z, all that stuff. And people thought that was awesome. And then obviously you had Realm of Excursion, and a lot of the Realm of Excursion videos got uploaded to YouTube. And that was like my first view of real car audio. And I remember one of the main videos that really got me into car audio and made me go, I want that when I'm older, was a video from Realm of Excursion of a Kicker Solo X18, and it was in the jankiest looking car you've ever seen. It was like a dusty ass car with steel rims, like grey, dusty. The license plate was all bent and stuff, and it was a Solo X18 in an MDF plain box in the back. No idea what amp it was on, and it was just a compilation of clips of the woofer flexing the car, the wind mirrors, and flexing some glass on a shop window, and also flexing the rubber tires, which was really cool. And obviously the camera mic was clipped to fuck, which sounded good on the small speakers that people were listening to. And then you've got that, of course. But that was my first insight.
Wait, what? What do you mean?
What are you talking about? What are you talking about?
Oh, man, this is good. This is comedy gold right here.
That's 13,000 views right there, bro.
What? Oh my god, fantastic! What is it? Stop motion? Did you make this?
Yeah. So basically, I just was pissing around, and that.
Dude, that's awesome.
So good.
I love it.
Oh, is he frozen or am I frozen?
He's frozen.
Oh shit. You broke him.
Yeah, I broke it. Oh, my bad.
You broke him.
Shit.
Stream over.
Hey, no. Tar
Yeah,
amps took him down.
Yeah, for real. Hey, do you remember that? Remember when Kako got taken down? Like as soon as like the FI thing happened. You remember that?
As soon as what happened?
So the FI, the Tinsel lead started getting burned up, and they started blaming all the Korean amps. And like right after, there was like a huge thread, and then right after that, Kako just got shit on. Everybody was like, "FI took the site down." It was like a big deal.
Yeah, they did too. Don't let them tell
They
you.
100% did. I don't know who's to blame, but yeah, definitely. My internet is so bad it kicked him off. That's how bad mine is.
It couldn't handle the draw.
Seriously, dude. He said he was like 13, 6 years ago. Is this kid 19 years old?
No, 2006.
Oh, okay.
2006. He was
6 years ago.
Hey yo.
Did I die or did you guys die?
Yeah, it was you.
My internet is so bad it tore yours up. That's what happened.
Yeah. It sucked down the drain.
Over here.
Yeah.
I
wish I could move these around. Wait, let me try this. Wait.
Yeah, I don't really need to be on camera.
My bad, I messed up.
I really don't.
Yeah.
Yes, another crotch shot.
Yeah.
Speaking of BareVids, just do this without your pants on, and maybe we'll get some more viewers.
Yeah.
So do you guys want to know a funny story about the
always
BareVids as well?
Of course.
At the time that I created the YouTube account, unknown to me, I had no idea that this was the case. But the BareVids was actually the name of a porn website. So if you Googled BareVids, then you would get a crap ton of pretty interesting photographs. And I was like pretty pissed. I was like, fuck. If I'm saying to some people, hey, go check out my channel BareVids, and they Google BareVids, they're going to be getting a completely different type of entertainment. So that was a bit annoying. But that website no longer exists, thankfully. So I'm the only BareVids now.
That is hilarious. Is it still up?
No. I think the website is dead now. The BareVids porn site. So,
bro, honestly, I don't know how you're doing that. That soldering iron looks like 3 pins wide. Like, this
is really janky because I'm trying to get this up and running really quick. But this is really, really janky. This soldering iron is not the right one for this job. I need to change.
That's fantastic. Mike Diaguardo says you're a Cockney bruv, whatever. What is he saying?
Can I see the I can't see the comments, can I?
Yeah, you should be able to.
Yeah, on the
private chat. Oh, here we go. Live.
Yeah, live comment.
Yeah. Right, there we go.
They're gonna be super delayed for some reason, but you can see them. That's all the Facebook and YouTube.
Yeah, no, I got him. I got him.
Shout out, Mike. Mike was one of the first ones on this Brazilian gate, huh?
Yeah. Well, he did like the whole.
I don't watch anybody's videos but mine.
No, he did the oh my god, Faraday cage around the tear amps and got it to clamp correctly.
No, I don't remember that. Hey, just dump it over the whole thing.
Yeah, for real. Oh, look, he is.
Yeah, there you go.
What the shit?
Dumping it over the whole thing. So basically, this the solder on this is old as fuck, and this board is very, very cold. So this board has been left in the workshop, and I haven't preheated the board. So essentially, all the heat that I'm applying with the heat gun and the pads, it's just being sucked away. And I can't be bothered to get the heat gun out and preheat the board.
Are those supposed to touch each other?
No, of course not. So what you do is you load it up like this, right? And then once it's loaded up and you know that the pads are making a good contact to the pins.
We're about to learn something.
Then what you do is you can take your solder sucker and you can suck the rest of it away like this. So it's just you can cook the rest of that up again. So now that they're actually making good contact on the board, take our solder sucker and we just start to clean it up. Suck the rest of that solder away like that.
That's what they call me, the solder sucker, because I'm terrible at that shit. Like, oh my god, I would need like those microscope glasses to even approach to be able to do that.
Yeah, I'm not doing this. My amp's just gonna stay broke.
Right, for real. Just fuck it.
This is janky as fuck, but it's a Tuesday night and it's like.
Well, you're also live streaming.
Yeah, right.
Although you do live stream amp repairs, don't you?
I do. I live stream. I haven't done any for a while, but I've live streamed my amp repairs for a couple of years now. Yeah, it's pretty good fun. Keeps you on your toes. There you go.
What?
That's clean enough.
Why does that whole amp look rusty?
Oh yeah, this is this amplifier has had many a repair by previous technicians. So this came in from this one originally came from Poland, I believe. This amplifier. There's been a bunch of techs that have had to go at it. So you can see here that there's a bunch of crap over here on these MOSFETs, and where this amplifier blew, it actually completely took out the trace to this leg. So there's a bunch of old solder plugs, a bunch of old soldered attempts. Yeah, it's pretty janky, but we'll get it working.
Yeah, it's just gonna send it. So what do you see? What do you see fail mostly on these full bridge amps? Is there just a common thing that goes first?
Nothing any different to half bridge amps. So okay, I'm gonna go ahead and talk about full bridge amps now, and probably change some opinions on what these are. So essentially, people have got some misconceptions about Brazilian full bridge amplifiers. The first thing that I hear all the time is that these are digital amplifiers. That is a marketing buzzword. There's nothing about these amplifiers that is any more digital or analog than your standard Korean half bridge that you're used to. The reason that the word digital has come into play here with marketing is only the way that the amplifier's initial turn on and protection circuit is controlled. So on old school amplifiers, you'll have a bunch of like switches and stuff that turn the amplifier on after a delay of a second, and the protection circuit kicks in if the voltage drop across a resistor is a set amount. On these amplifiers, on all the newer Brazilian ones, and not just Brazilian, like Alpine are one of the best for this. And you've also got Orion and Directed also use this kind of digitalness. What they do is Taramps or these companies will program a chip with some firmware or some preset defined values that make the amplifier come on and control the protection circuit. So the way that the amplifier section is working, the actual Class D operation is no different to any other amplifier, any other Class D amplifier out there. So it's not the amplifier that's digital, it's just the kind of turn on control or the protection circuit that's digital. So don't get caught up in an amplifier being digital or not digital, because the amplifier part is kind of the same. It's just the fact that they're like, oh, hang on, we've put a chip that we've programmed in this amplifier, so we can now call it digital because there's some data in there somewhere. So that's just a buzzword. The second thing that I see a lot is people say that these amplifiers are, the Brazilian stuff is higher voltage amplifiers, and therefore it's more efficient and all that stuff. So actually, on the contrary, full bridge amplifiers, whether Brazilian or not, any amplifier that works in full bridge, and that what I mean by that is that the speaker terminals, the plus and the minus speaker terminals, both have a sine wave on them. In a half bridge amplifier like your Korean, your Sundown, your DC, ground zero, only the positive speaker terminal has a sine wave on it, and that's doing the pushing and pulling of your speaker. The negative is just a common ground, so it just takes that and grounds it to complete the circuit. On the full bridge amplifiers, you have a sine wave on both positive and negative, and they push and pull. So in a full bridge amplifier, there's actually half the internal voltage of a half bridge amplifier. And the reason for that is with a full bridge amplifier, where you've got both positive and negative speaker terminal doing work, in order to create, say, for example, 200 volts potential difference across the speaker, with a full bridge amplifier, you put positive speaker terminal to 100 volts, negative speaker terminal to minus 100 volts. And now you have 200 volts across those two terminals. So the speaker sees 200 volts. However, with a half bridge amplifier, the negative speaker terminal isn't doing anything. So you have to, in order to get the speaker to see 200 volts, you've got to send 200 volts to the speaker. So you need 200 volts of rail voltage inside the amplifier. Whereas with a full bridge amplifier, you only need 100 volts of rail voltage, and you just invert the phase of the speaker terminal so that they end up seeing 200 volts. So saying that full bridge Brazilian amplifiers are high voltage is kind of the wrong way around. The half bridge stuff is a higher internal voltage, and that is one of the reasons that Brazilian amplifiers and these new full bridge designs can get away with having such small amplifiers for such high power. When you look at the things in these amplifiers that actually do the power, the MOSFETs, let's just take an example. So here we have a MOSFET for you guys. These are the things in the amplifier that are actually doing the power. Okay, and just like any other electrical component, okay, as the voltage rating of these goes up, so the higher voltage that these need to accept, the lower the current that they can handle. So if you have, like I said, a half bridge amplifier needing double the voltage of a full bridge, with a half bridge amplifier, in order for the thing to accept, I don't know, say 200 amps, you're going to need double the amount of MOSFETs than a full bridge amplifier, because the half bridge amplifier needs double the voltage. Therefore, each MOSFET isn't going to be able to handle as much current. Whereas in a full bridge amplifier, because you have much lower rail voltages, you can get away with using insanely high current MOSFETs on the output section, because you only need a lower voltage handling. So that allows these amplifiers to use, literally, in this 8K amplifier has four MOSFETs on that side and 4 MOSFETs on that side in the output section. So 8 MOSFETs are able to create 8,000 watts RMS at 2 ohms. And the 15K versions are the same. They also only use 8 MOSFETs. So these are insanely high current, lower voltage MOSFETs that do the work here. And they are very, very low resistance as well. So when people say, these amplifiers, how can they be so small yet put out so much power? The reason for that is just because they're a more modern design and they're using more modern components, not because they're high voltage, not because they're digital, just literally because they are new. The big old school Korean half bridge amplifiers that you guys know and love, like the Sundown, DC Audio, Digital Design, the Ground Zero, blah, 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 all that stuff that you consider a solid amplifier. Those designs, those actual circuit designs, are like 20 years old or more. They are freaking ancient circuit designs. And the reason that they're so big is at the time that those circuits were designed, MOSFETs didn't exist that could do as much power as they do now. And so you needed more of them in parallel to produce a certain power output. Whereas now, MOSFET technology in 20 years has come a long way. You only need a fraction of those MOSFETs, coupled with the fact that they're full bridge, so you only need half the rail voltage. You can make a 15K amplifier possible from as little as 8 output MOSFETs. And that is a better solution. People think that size is everything. You have a big amplifier, it must be big power. But remember that with length of copper and length of wire and trace comes resistance. So the smaller you can make your amplifier, the less distance the power has to travel across the board traces, etc. Therefore, the less losses there are inside the amplifier. So it's beneficial to have the smallest amplifier possible.
Yeah,
so
but
that the current coming into
you also don't
amplifier,
get the heat dissipation though.
Yeah, exactly.
And the heat is what kills, vibration and heat. Mostly,
yeah. The main killers of amplifiers.
That's why they got fans, bitch.
Vibration. Yeah.
So okay, so it sounds like you're a fan of full bridge. It sounds like you're a fan of Brazilian.
I think it's going in the right direction. I don't think they've got it quite right yet. A lot of the brands.
So
but
explain
in the right direction.
So explain to us all why Brazilians are made of glass. Like, why do they fail so often?
So they don't fail as often in Brazil, which is interesting. That's why when you're
It's American user error. It's American user error.
Obviously.
Kind of almost.
Stupid Americans.
I want to run headphone.
Yeah, it's not American user error. It's just the way that us in America and Europe and stuff use them. So the Brazilian car audio scene, the way that they do things, they like to whack a crap ton of PA-style subwoofer drivers, and they play much more punchy, higher bass-style music. And they run the amplifiers at a lower voltage. Generally, it's all engine off, and so the amplifiers are all rated at 12 volts, as you know. So a car amplifier will do power between 9 and 16, 18 volts. But the names of these Brazilian amplifiers, they are named based on their 12-volt rating as opposed to being named based on their 14-volt rating, because the majority of users in Brazil are running these things at 12 volts. So when running these amplifiers at 14 volts, the components inside are slightly more stressed and slightly nearer to their voltage limits than they are at 12 volts. That's one thing. The second thing is that in Brazil, like I said, the types of woofers that they're using are PA style, and the type of music they listen to is dance style music that has more punchy kicks. So the average power across a 3-minute period is insanely less than the type of bass music and stuff that you'll have in America and Europe, with decaf music like hip hop that has low, continuous long bass lines. So these amplifiers are designed to produce the power that they state. They do make rated power, but the way that they're designed to do it is in short bursts, like with kick drums, and at a higher frequency, and with using PA-style drivers that have a much higher inductance and efficiency, and therefore the impedance rise that they present to the amplifiers is much higher than the likes of the inefficient, big, slow, sluggish stuff like the Sundown, DC Audio, Ground Zero style woofers that we use over in Europe and the States. So when we put these big, low efficiency, low inductance drivers on these Brazilian amplifiers and ask them to play a constant 30 hertz sine wave for like 3 minutes, the amp is not designed to do that. It gets too hot. The power supply transformer saturates, the power supply FETs die. The output FETs, if they're not completely balanced properly, which they never are, in some amplifiers you'll have like 2 FETs doing most of the work, and if with a continuous sine wave, the heat doesn't get shared and they die. It's the way that they're used over here that makes them more fragile than over in Brazil. And that's why that if you are a distributor or a dealer of these amplifiers in any of these countries like Europe and America, and you go back to the company and you say, what the hell, man, like I've got too high a fault rate, these things are dying too often, what's going on? And then they come back and say, we haven't had any problems, the guys, we don't really get money back in Brazil, and they will then say that it's not an amplifier fault, it's the way that they're being used fault, which is kind of true, but also kind of not. There is a problem with the amplifier. It's not designed for how they're being used in that country, but they don't see it as a problem because they don't have those issues where they're made.
Hashtag stunt wall is life.
I'll kill you.
You know what a stunt wall is, sir? Sam?
Hmm?
You know what a stunt wall is?
Stunt wall.
Yeah. No, that's third strike, bro.
Yeah,
that's honestly.
Wait, what the hell is going on with this camera anyway? Why is it frozen?
I don't know.
It just
because as soon as you said sundown, ancient technology, and suck, then that's Dude, Jacob made a call to Prime Minister of
Harlem.
I never said suck. I still would generally recommend
Ancient
for the
technology.
Majority of people, I would still generally recommend the old half-bridge designs because they're so old, they've been perfected. So they've had 20 years worth of tweaks and worth of like bug like checking, and basically they are now as good as they're going to be. So I would still recommend those. That's why they're so reliable. Generally, I see a lot of them, but they are more reliable than the Brazilian stuff.
Dude, I'm not buying it. I'm not buying it.
I don't fades on a tangent. Let's go.
I don't buy that explanation.
Keep it going.
So old. I mean, Full Bridge has been around for what, 50 years? I mean, figure this shit out.
No. Full bridge isn't the new thing. It's just the Brazilian circuit design. I mean, the Brazilian circuit design isn't anything special anyway, but it's just the amplifiers that the Brazilians are making are not. They're not fit for purpose and how a lot of Americans and Europeans use them.
You mean like properly? Like I don't know. I don't.
Stop using Brazilians on bass, bro. PA.
Stupid. So okay, when they don't like alternator voltages, no one has 1,000 amps of alternator voltage anyway that are current. So everything is in the 12s anyway. People just clip them to death, and they clip Koreans to death. So why do they get clipped? They get beat to death because they make too much power, and they can't handle the lower reactives. No.
Yeah, they will die sooner than the Koreans will for a number of reasons. They haven't had the bugs ironed out as well as the Koreans have by now because they haven't been around as long. Okay, if you just look at them, the amount of capacitors in them, for example, like when it comes to where the hell's my camera gone? So if you're clipping the crap out of an amplifier, okay, then the amplifier is going to need to provide much more current than it is designed to provide. Okay, this thing, I can tell you now, this transformer, when this amplifier is making rated power, is very, very close to saturation as it is. If you clip it on a low inductance woofer, then this is going to enter into saturation, which causes a short circuit environment across the power supply FETs. So that's why the power supplies die on these so often. rather than the output sections. You tend to hear the thing of like tower amps always going off on fire, like smoking like crazy. When an amplifier smokes, it's because the power supply section has died. The smoke that you get from an amplifier is when the power supply MOSFET's short, they create a short circuit across your plus 12 and your ground. And so until you remove the power wire, or until they've just burnt up so much that they go open circuit, they cook and they create all this plumes of smoke. So that's why you'll find that Brazilians are associated with smoking and fire, because the power supply sections are the things that die first, because the transformers are close to saturation already, and when you clip them and stuff, they go into saturation much sooner.
Is it fair to say that Brazilians or full bridge are they're being run closer to like quote unquote red line than
much closer to red line in the way that America and Europe use them. In Brazil, they're not run anywhere near as close to red line, because the current demands from the amplifiers, the way they use them in Brazil, are much lower, because impedance rise is higher, therefore current is lower, and also because the bass notes are much shorter and more impulsy, the average current over time is much less than the hip hop style of music. So they won't saturate.
Have you seen any of the newer? I guess the newer style of the tar amps that they've come out with, the MD line and the bass line, or is this strictly the HD line that you're talking about?
So I'm talking in general. Like the HD line is the stuff that's been around for a while, and that people have. That's what people associate with like the Brazilian style of amplifier.
Right. I feel like that's the one that's having the biggest issues. The HD line, the whatever they got, 15Ks. They're trying to run.
Yeah, the HD line was designed for Brazil. The MD line is like the Rev 2. So, like I said, the Korean amplifiers have had 20 years of revisions and stuff to iron out all the issues, right?
Ancient. You said ancient.
You did.
The MD line is like the second stage of that. It's like they've looked at the HD line and they've thought, right, what don't people like about this? What are the issues that are happening? And they've tailored it more towards the Western market in the American scene and the European scene. And they are allegedly supposed to be more reliable now with how we like to play them. And they've had various changes and tweaks and optimizations made to the drive circuit, etc., to make them perform more reliably.
We tough on shit here, man. We tough. We just want something to put in, wire down low, crank.
Just beat it.
Well, what I will say, I'm talking about Brazilian amplifiers as a whole, but if you want an amplifier from Brazil that is hella cheap, that will do what you want it to do, like the old Korean stuff, the Vennard amplifiers are designed for the European and American market.
Fade. Fade said no to your Viking.
I just put. Did you see the picture I sent to the chat? There's one on the wall. It's messed up.
Send it over.
Yeah,
I do. So, maybe I will send it across the pond. Why is Banda better than say the others?
All you need to do is just open the back of them and take a look inside. So
they do feel beefier. That was one of the very first things I noticed.
This is just noob stuff. Okay, like looking in the amplifier, it's like looking in a car engine and saying, "Oh, I don't know why it doesn't run. No, the engine's still there." But no, if you look inside a Taramps 10K, a Sound Digital 10K, and then the Banda Viking 10K. Okay, all three of those amplifiers are rated to do 10,000 watts at 12 volts at 1 ohm. Okay, inside those amplifiers, you'll find very, very, very similar circuits, almost the exact same Class D output section. However, the Banda Viking has twice the amount of component. It has twice the number of MOSFETs. It has twice the number of output sections in parallel. So it will do the same power, but it will stay twice as cool and be able to do it twice as long. So if you take the Taramps version, which has 8 90N20D MOSFETs in the 10K version, okay, and you play that for 3 minutes at cloud power, it will get, I don't know, X hot, okay? If you take the Banda, which has 16 90N20D, the same FETs, but it has 16 of them instead, then the power is shared across 16 FETs rather than 8. So therefore, each FET will get half as hot, it will run more efficiently, and the amplifier will be able to play much, much longer. It's just a much more beefier kind of play for the demo for hours version of the circuit.
Years ago, when I used to do cool things, I tested like a bunch of different amplifiers to get all the Brazilians, and the Banda was the only one to survive. Like the other ones,
Then why'd you give it a thumbs down?
Popped. Because I first of all, I don't like the fact that they send you like 150 amp fuse on a 10K. Like, what's the
that's bullshit. So there's a lot of bullshit. Don't get me wrong. There's a lot of bullshit with Banda. They're not perfect because there's a lot of crap with the company as well and the way that they're doing things. But if you're just looking, if you're taking away the brand, taking away the company, if you're just looking at the circuits and the design of them and the components on them, out of all of the stuff coming from Brazil, the Banda is the thing that you want to put in your vehicle if you are slamming big like power woofers and long demos for hours. They're the boards that you want to put in them. I don't like Banda very much. I used to distribute their amps to the UK. They fucked me over on pricing. They put shit fuses in their amplifiers.
They shouldn't even mention them.
Yeah, but as a circuit, like I don't like forgetting the company, forgetting what fuses they put in there, whatever. As far as the circuit goes, they're the best thing that I've seen come from Brazil so far. Korea have now started making these kind of full bridge amps.
Yeah, but they're just copying Brazil. That's all they're doing. They're not innovating anything.
Not really. So the stuff from Korea is doesn't really share a lot with the Brazilian stuff. The actual circuit design is a lot different. What the Korea have done is they've taken their old half bridge amplifiers and they've taken all the MOSFETs out. They've said, right, what MOSFETs are now available that we can put in these amplifiers instead to make less of the MOSFETs. So they put in much higher current MOSFETs and lower voltage because they're now half bridge. And they've taken the same drive circuit, but they've just doubled it and then flipped the phase of one of the sides. So essentially the Korean full bridges are just two of their half bridge amplifier circuits on the same PCB with modern MOSFETs, whereas the Brazilian stuff is using much different drive circuit, much more modern drive chips, and using PIC controlled power supply and protection circuit. Whereas the Korean stuff is still using the same ancient TL494 style power supply. The Korean stuff is basically an old amplifier, but kind of made full bridge with modern MOSFETs. Whereas the Brazilian stuff is mostly all new parts.
You know Jacob Fuller's
Jacob, ancient piece of shit.
It's garbage.
So what do you think about their new full bridge line coming out?
I haven't tested. I would love to test them
because
also? They have done the Sundown new full bridge stuff, the Salt line, all the pictures I've seen from the Sundown side of it. Looks like they're doing the right sort of thing. They're doing the modern parts and the modern stuff, the high efficiency, low RDS stuff properly with all modern drive circuits and PIC control power supply, etc. Checking before going full duty cycle. They're doing the right sort of thing. They're not just taking an old design, making it a bit more efficient, making it more modern parts, and full bridging it. They're actually doing something that's new. So I'm looking forward to testing the new Sundown stuff. I'm happy that they're doing that and that they go.
Nah, they cost too much. Fuck out of here.
Yeah, it's terrible.
Nah, 180 on eBay for a Stenson 3K. Fuck out of here, Jacob. I ain't paying that kind of money.
Bullshit.
I got one right there.
Hey, speaking of Jacob Fuller, since you're in here, Jacob, we got to get you back on. You're gonna be like our first.
What fuck we do?
I just
why?
I said it. I'm announcing it.
No.
Yes.
Fuck out of here.
Arm wrestle for it.
He's got that other. I'll destroy you. Look at this thing.
Oh
shit! Look at that thing, dude. Look at this angle here.
Skip needs
somebody. Look at that. It doesn't. It's bigger than my head.
Hey, we got to take some questions from the chat. So, Sam, go ahead and finish that amp. So, because we gotta cut the hard line at 8, so we gotta get out of here. I want to see this amp working. We can't distract.
Yeah, so I've been chatting too much shit. Like I haven't been doing any soldering for a while. So
yeah, bad. More drinking, more soldering. And
I had one from Mike.
If I get these, actually, I think everything might almost be ready to go. If I can get this transistor in.
I don't know what this.
I think Mike is the only one that wants to hear him explain cross conduction issues. Like I would rather hear about intermodulation distortion or crosstalk or something. Like I don't even want to hear that shit. Yeah, that's what we're trying to get to. I know the chat is way behind. Oh, is Ray Rayfield in the chat? Oh, that would be interesting. Have you ever heard of linear power, Sam?
I've heard of phase linear. That's the old school amplifiers, and you used to get a power supply, like big thing amp, and then you used to run all the amps off that power supply thing. That's phase linear. I've heard of those guys. What was the name that you said?
Linear Power. They're like more of an
Power.
SQ oriented brand here. Just throwing it out there.
Phase linear were SQ for sure. I don't know if it's
someone said Ray
purple.
Rayfield, the owner, was in the chat.
That's as far as I can flex, guys.
That's it. That's all you got.
Can I? No, I was gonna say something.
Uh-oh. So all right. So have you kept up with the Term Lab cheating? While you're doing that, can you answer that question?
Yeah. So when you told me about that, and that wanting to talk about that on the stream, that's the first time I'm hearing of it. We haven't had any of that in the UK. I don't follow the US testing closely enough to have found that out. So
you're saying there's no cheating going on in the
There's
UK?
no cheating going on in proper
in
droppers.
Europe, there's no cheating.
No one uses those no one uses that sort. No, not really. Like the UK basing is very, very small. You have to understand this. It's like everyone knows each other. It's like a little family. Like it's very, very, very small. So generally, no one needs to cheat with that sort of thing because there's not enough competition to warrant that.
What do you run in your own car? That's what I want to know.
So I have a van, which is like my SPL van, and then I have my Proton, which a lot of people remember from my YouTube channel, which is now an SQ vehicle. So in the van, I run an SQL-ish style front end. So it's a couple of bullet tweets on the A pillars. Equal distance, 6.5-inch DDA series, the German SQ series mid on the pillars, so they're like perfectly in.
You have 6.5s in the pillars?
Yeah. It's
Phase triggered. Phase triggered.
I am triggered.
You lost them at bullet tweeter, but go ahead.
The bullet tweeter I wouldn't have chosen. So I bought this van from one of my customers. He had it built and I supplied the equipment, and then he sold it like a few months later after having it built, and he offered it to me at a really good price. So I took it, and it already had the bullets in it, and they sounded all right, and they kept up with the bass. So I haven't chopped them out yet.
Dude, if you keep them crossed over high enough, they're fine. Like everyone listening right now that thinks I'm gonna shit on bullet tweeters. Keep them crossed over at 8K.
Provided like you say, crossed over high enough, and provided that you have them cranked down enough. Like bullets are incredibly efficient. You don't need any power if you're in close range to them or on axis to them. The only time that bullets are effective is if you are miles away from them or very off axis to them. If you're on axis with a bullet and it's within close proximity, you need like freaking 3 watts, and it's like too much.
That's a bail for T-Fade. What else you got?
So yeah, that in the van, and kick bass, there are 4 10-inch DDVO 10s behind the seats. And then the bass is a 6th order wall with 2 DDZ 415s carbon with all the fancy bits on them. So yeah, it's just pretty nice.
Is it against the law to say Z in y'all country?
Yes, they say Z and they say H.
No, Z isn't anything. Z doesn't exist. That's
Z.
It's the
no
last.
one says Z.
It's the last letter in the alphabet.
Z and H. I'm telling you, that's what they got.
But yeah,
what amps? What amps you didn't?
Amps is all the front end is all on Genesis amplifiers, which is like a high-end SQ brand. The bass is on. Now this is how do I explain it? I won't go into it too much, but it's on a pair of 4.5K 1 ohm rated amplifiers, but they are strapped at 0.5, so each amp sees 0.25, and that's daily. And the reason I can do that is because of the ridiculous inductance of the Z4 woofers. The amplifiers actually stay cooler running at 0.25 than they used to run at 1 ohm on my old subs. That's how crazy the Zs are. So if you're considering running DD-Z subwoofers, in order to get the most out of them, because they are such ridiculous high motor force woofers, the impedance rise will be through the roof. You need to wire your amps down. So yeah, they're at 0.25 daily, and the amps are cool as hell.
Yeah, it's hilarious.
The old compact Neos have a bit of rise to them too, just in case you ever think about switching.
Nah, man. So that's the van, and my daily.
Nah, man, not sundown, bro. Nah. Get out of here. Nah.
Is not
kind of not really. Kind of not really, bro.
Also the wouldn't fit either. The box is made for the DDSP, which is a slightly bigger cutout, so it won't fit.
So have you've metered it, or what we talking?
I metered it ages ago on 1 amp, and it was doing a 1. It's a musical build, so there's low port area, so it's designed to be flat. It was peaking at 25 hertz with a 154 ish. On a pair of 15s, and now I've got the 2 amps in, and at 0.25 it feels like 4 times louder. I haven't metered it yet though, but I imagine it's probably around a 156.
Nobody plays music on DDZs.
Huh?
Nobody plays music on DDZs.
You need to talk to Michael Shirley. He's got a build doing with 4 DDZZ 15s. He's got them on 4 M5s at 0.5, I think it is, and he gets 165 at 34 hertz with 0 clip, and it's musical.
All right, get back to the controversy.
Yeah,
feed.
I'm sorry.
Explain.
I was trying to give him a softball while he's repairing.
Nah, we just get to the shits.
Just chat whatever you want.
Yeah.
Bro.
So, all right. So explain what the what happened at finals. If you want me to, or are you going to? Or?
No, you got to tell it. Oh, you got to recap for Sam?
Yeah. We have to recap for Sam because he didn't see it. All right. So I'm gonna explain it wrong, and everybody's gonna laugh at me, but I don't give a fuck.
Yes.
So at finals, there was some kind of controversy with a Brazilian app, a Sound Digital. If I'm gonna just shit on them, I mean not shit on them. They do what they do. I have one. I'm gonna try to cheat too. I don't give a fuck. And so anyway, it's a Sound Digital 12K, and the classes that both of these vehicles were running, it's a pair, it's a couple. It's a girlfriend and a boyfriend. So the classes are limited to 1,000 watts and 5,000 watts. So the conspiracy is people are thinking somehow they're either modified the amp or using some kind of phase trick to make the clamp of the TermLab Magnum read a lot lower than the actual amp is sending to the subwoofers.
Yeah. Okay.
So that's the controversy.
You said to me that this was unintentional to start with.
Well, the guy we found who did it I mean, it's people has been knowing about it for forever, probably. I guess, but
it's intentional.
Yeah, these guys, the accusation is they did it intentionally. But the first guy that we showed, he just like Adam Kim Russell, he just stumbled upon it and showed us, But these guys, the accusation is they are doing it on purpose to win a class and cheat the meter to show less power so they don't break out of the class, if that makes sense.
Yeah. Well,
is that possible on a Brazilian? And how do I do it? Send me instructions. Yeah, give me your address.
Obviously, that's like kind of pointless to cheat that because
I mean,
you said it was 200 watts or something, and then the real was 4,000. So it's a bit ridiculous.
That was the original guy.
That's the plan.
Yeah. That's what we want to do. Like I said, the class is limited to only maximum 5,000 watts.
Yeah.
So
10,000.
Yeah, but I want to send my subs 10,000 watts so I can win that class. Yeah. But I want to show the meter, the clamp meter, is only reading 3,100. Is what he always was doing. How do I do it? Go ahead.
Well, explain. You need to probably learn a bit more about SPL competitions and do it properly, bro.
Hey,
properly.
No, I don't want to do that. I want to send you. I want to do it. Go ahead.
So if you want to cheat, so basically, as far as I understand it, with how the clamp meters work, it's a Hall effect sensor. So what the clamp meter is doing, what the sensor is doing, is it is converting it's listening to the magnetic field created by the current flowing through the cable, and it's using a reference voltage on the Hall sensor to detect how much current is passing through the wire based on the strength of the magnetic field created. Okay, if it's DC that's being sent through that cable, then it's relatively easy. There's no frequency involved. It just literally needs to measure the way the Hall sensor works is the electrons get pushed against one end of it. with a magnetic field. So the strength of the magnetic field determines how many electrons get pushed to one side of the Hall effect sensor, and that then it converts that reference voltage into an amount of current, and then it can work out obviously the power. With AC, from what I understand, I'm not an expert on Hall effect sensors or the clamps, but from what I understand, it needs to detect the frequency that's passing through the cable in order to figure out an RMS style reading, so it knows how much current is actually being passed through the cable.
Yeah.
And because it needs to know the frequency, there's obviously a kind of a code, an algorithm that is listening to the Hall sensors voltages going backwards and forwards, and that will have a refresh rate. So it will take a sample of the voltage on the Hall effect sensor every X amount of microseconds or whatever frequency it's doing it. So the way that these Brazilian amps work, because there is no filtering on the output. So basically, essentially what's happening is the output MOSFETs have a great big square wave on them at a stupidly high frequency, like 300 kilohertz, which is obviously way over any audible range. And the sine wave is modulated on that frequency.
That's lower than others, though, right? Do Brazilians do it lower, the carrier frequency?
No. Brazilians do it high. So Brazilians do it high. So a Korean amplifier, generally the output switching frequency is around 125 to 150 kilohertz. On a Brazilian, it can be anywhere from 300 to, I think the highest I've ever seen is like 700 kilohertz. And the reason for that is all these amplifiers, these Brazilian ones, are full range. So the higher the switching frequency, the more samples you have of the sine wave that you can build, therefore the higher frequency you can play while sounding nice. If you think about it, obviously the higher frequency you go, the more ups and downs there are per second. So you need to have more samples of the sine wave built per second. So the frequency needs to be higher of the Class D switch. So yeah, the Brazilians are always much, much higher, but they don't, basically with half bridge amplifiers and the majority of the Korean amplifiers, they have an inductor that is in series with the output MOSFETs, the drain that creates the sine wave, and that inductor will filter the high frequency switch wave,
right?
So that the subwoofer doesn't receive it. The subwoofer wouldn't care about it. The subwoofer coil itself is an inductor, and it would filter it itself. However, the effect of filtering that high frequency would heat the coil. So even if you left your amplifier idling with your subwoofer connected, your coil would just heat up a little bit, just get a bit warm, which is not ideal, obviously. So they have inductors in them. With where full bridge comes into it, what they do is they use the fact that both positive and negative speaker terminals both have that same square wave on them, the same high frequency square wave, and so they don't need to filter it because there's no potential difference between positive and negative.
Oh, so they cancel?
Yeah, they don't cancel, but they don't create any potential difference. They're the same thing. So if the subwoofers, positive and negative, are connected to the same thing, there could be like 1,000 volt square wave on both positive and negative. But provided there's no difference between the two, positive and negative, the speaker sees nothing. It doesn't see any difference. What makes the speaker move is when it sees a difference between positive and negative. So provided they're both the same, it doesn't move. So on these full bridge amplifiers, because they're full bridge, the negative also has the same as the positive on it, so it doesn't need to filter the high frequency because it doesn't have any difference between the two sides. So
that's fascinating. Is everybody picking up what he's putting down? Skippy, you got that?
No.
Shit. Hopefully, I hope. Oh, no one's picking it up. It's like
see if I can do a draw of it. Maybe
it's fascinating.
Yeah.
Right. So
explain it like I'm 5.
Right. I don't know if this will be mirrored or not. I don't know if this will work in mirror image. So let's say you've got your average Korean amplifier, right? So on the Korean amplifier, you have the MOSFET, which is this thing. This thing's your MOSFET, okay? This has a big fucking square wave on it like this. That is what the audio signal, your sine wave, rides along. It rides along this great big square wave, okay?
Right.
So this is your positive. That's the amplifier positive, okay? and the negative is literally just a ground. So you connect your speaker to the positive, it goes through the voice coil and goes to ground. So if you have 125 kilohertz on the positive, the subwoofer voice coil is going to see that as a difference to the negative ground. So therefore, it's going to turn that into either energy, moving the speaker in and out, which it can't do because it's such a high frequency that the coil acts as an inductor and filters it. So you end up with 125 kilohertz worth of square wave going in and nothing coming out because it's filtered it, and it turns that into heat. Okay, that's
right,
why
so it's like a crossover.
Yeah, exactly, just like a crossover. So that's why half-bridge amplifiers have a coil in series, an inductor on inside the circuit, inside the amplifier, so that the subwoofer doesn't see this. It just sees the nice clean sine wave, which it can turn into kinetic energy and move the speaker backwards and forwards. And therefore, the thing that gets hot, this inductor inside the amplifier gets hot, and it's inefficient. It kills efficiency. It's just basically a heater that's eating up this 125 kilohertz and passing just the sine wave to the subwoofer, but in effect it eats up some power by doing that. If you have a full bridge amplifier, you have positive and negative. Now on a full bridge amplifier, both positive and negative have MOSFETs connected to them with this big high frequency square wave on them. However,
that one's out of phase.
It's in phase. If it was out of phase, the speaker would see a difference, but it's in phase. So this is at the same time as this, and this is at the same time as this. So the speaker that's connected to it doesn't see a difference because it's getting this high on both ends at the same time. So the difference across here is 0, and it's getting this low at the same time. So the difference across here is 0. So you don't need an inductor, because the speaker, the voice coil, doesn't see a difference. Therefore, there's nothing to filter. It doesn't matter. The only time the speaker moves is when the dead time, I won't go into this too much, but basically what happens is the way it creates a sine wave is that the dead time changes between this one and this one, so that then all of a sudden there is a difference of like 100 volts between positive and negative, and then it pushes the speaker outwards. Now, the problem is when you introduce a clamp meter to one side of it. So the clamp meter is taking a reading from just one side. So it's actually seeing all this noise before, because you have a resistor here and this one here. So it gets a bunch of noise, and it doesn't quite, these are never quite in phase properly. So if you look at it on a scope screen, which is why I'm trying to fix this for you now, so I can show you what it looks like on the screen. When you look at it on the scope screen, a half-bridge amplifier, if you look at the scope, when you look at the scope screen, this is your scope screen here, this is your middle point, the sine wave is a nice line, okay? And it looks nice and smooth. However, on a full bridge amplifier that's working like this with no output filtering, the sine wave actually looks like this. It's like loads and loads of little scattered dots like this. Okay, because of how the amplifier is actually creating the sound. There's no filtering, there's no smoothing. That's what the subwoofer sees. Because the subwoofer is a great big voice coil, it smooths this out. The subwoofer acts like a kind of smoothing, and the subwoofer basically just reacts to the general shape of the bits of voltage that it's seeing. But the scope and any electronic measuring device will see the raw voltages coming from the amplifier as tiny little spikes and dots like this. And you know, before I mentioned about how the Hall effect sensor will use a sampling frequency. So if you can marry up the frequency of your amplifier sine wave, and you can get it to kind of negatively construct with the sampling frequency of the sensor, then because it's AC going backwards and forwards, the sensor won't see any current, because by the time it takes the next snapshot, the current or the direction of current is back in the same place as it was before. So it doesn't really see any difference. It would work fine with DC if you were clamped it onto the power inputs from the battery going into the amplifier. It would work fine regardless whether the amplifier was Brazilian, Korean, whatever. It would be fine because it's just DC coming in. It doesn't require work on a specific frequency. But as far as I am aware, as far as I understand how these things work, the reason that you get inconsistent results with unfiltered amplifiers on Class D like this is because of the way that the Hall effect sensor is picking up the AC signal and the way that it's in like little samples rather than being a nice smooth sine wave. So you can kind of marry the frequencies up to make it appear like the sensor doesn't see any difference between when it took its sample to when it took its next sample to when it took its next sample. It's like, oh, well, the magnetic field across this wire is the same as before or about the same as before, maybe a little bit different. So that's like 200 watts. Whereas if you have a nice smoothed filtered sine wave coming out of the amplifier that the Hall effect sensor can read and that doesn't fluctuate so much that you can't marry it up, then it will be able to correctly determine the frequency and how much magnetic field there is around the wire at that frequency, and therefore create a reading for correct power.
So the chat is going to lose their effing minds if we don't mention that the Term Lab clamp is not a Hall effect, but I mean they're pretty similar in the way that they take their measurements.
What's the Term Lab? What's the Term Lab sensor? I did some research before the chat, and
it's an AC clamp, but they both use the Hall effect. Like one, like I don't understand why the animosity in the chat. I don't know. The chat is way behind what we're talking about, so we won't see it here for a minute. So go ahead and keep doing your thing on the amp, and maybe
I'm so much smarter now.
Yeah, no, that like I don't know everything I've said. I'm not an expert on the clamp sensors. I repair car amps. I have never taken. Yeah, just for anyone that's watching and it's like, what the fuck is he talking about? So I've never taken an electronics degree. I don't I've never done any classes in electronics or in magnetic flux like lessons or anything. All I've done is I have learned how to repair car amplifiers only. That's my specialty. And so I see how these things work. I see how they die. I see what they give to the speaker. I understand how electricity flows and works. I don't understand how clamp meters work. I'm not an expert on them. I've done some research on them, and I'm kind of thinking, what's the difference between how the full bridge amps work without filtering and the other ones? Why would it create a problem with the Brazilians and not the other ones? And that's just kind of the pieces of puzzle that I've put together in my head. Whether it's accurate or not, I don't know, but that's my interpretation of what's happening.
No, you got it.
I might come back to this video in a few years' time once I've if I do some proper classes on like clamp sensors and Hall effect and stuff like that, and I'll probably come back to the video and be like, oh man, I was chatting absolute bullshit. That's not how it works at all. But at this point in time, that's the best explanation that I can give as to why that certain amplifiers without filtering cause a problem.
I think Mike seems to think maybe there's DC offset, but there's no DC. It's not a DC thing. Not happening.
If there was DC offset on the output terminals, the subwoofer would, rather than resting at its normal resting position, would be either popped out or sucked in.
That's not what it is, Mike. That's why I think
the difference. It will show you the difference between the positive and negative terminal. That's what it's doing.
I think his contention is there's DC on the terminals, and that's why it's not seeing it. But no, that's not. I don't even think that's possible. That's why I keep saying it's an AC clamp and not or a Hall effect and not. Yeah.
To be honest with you, with how all these amplifiers are changing in their design and stuff like that, I think that all of these power clamped classes in competitions shouldn't be taken on the amplifier's output to the subwoofer. It should be taken or based on power going in from the batteries.
Honestly, that would be.
I'll tell you why, because that would then encourage people to use more efficient and modern amplifier technology, which would drive manufacturers to create more efficient and modern amplifiers, because that's what everybody wants. That's progression, right? So if you've got one guy that's clamping 5K from his batteries, and the other guy who's clamping 5K from his batteries. But the first guy is actually putting out like 4.5K, whereas the other guy's using old amplifiers only putting out 3K. Well, obviously, the guy with the newer amplifiers got the advantage. So therefore, the other guy, if he wants to beat his score, or he will want to upgrade to newer, more efficient amplifiers, which is the way that everything should be progressing towards. More efficiency, less heat, less failures.
I'm there with you, baby.
Yeah, man.
I'm all over that DC clamp. All right, everybody, email everybody right now. Everybody tag Wayne, tag Steve, tag Janisa and the daughter, and who's the other one? How many other people we got to tag in here? We call those fuses. Yeah, that's true. Mecca they didn't used to clamp. They used to use fuses.
Really? So if the fuse blew, then
you were done. Yeah.
Power.
That's actually maybe we need to go back to fuses. Shit. I thought the clamp was the.
I loved Mecca. I loved Mecca when they had 100 of those tiny. Remember they figured out which ones they can use to run instead of 100 amp, they ran 25 amps.
Yeah, the audio pipes would not blow no matter what. It was just like
yeah.
Yeah, fuses are definitely not a reliable way of measuring power.
Next show, we need to interview an expert on clamps. I mean, who's an expert on clamps?
I would love that. I would love that. If you got someone that knows what they're talking about in terms of how the clamp meters work, I would love them to come and
we need to have Wayne on.
Prove me wrong.
Yeah.
Completely.
We're going to have Wayne Harris on because he seems to be an expert.
All right, guys. The God, Mike Dio, may be joining us in minutes.
Uh-oh. Here we go.
Share away.
Did you ask Sam if he minds if Mike joins us?
Do you know who Mike? I mean, Mike don't want them problems. That guy bare knuckle.
What's going on?
Do you know Mike Diaguardo? Nobody does, so you don't have to say
that's true. Yeah, you don't feel compelled.
Nope.
He knows slight stuff about electronics, but
I feel like that's an understatement.
Yeah, maybe. Yeah. No, but he was one of the first ones to be in on the Brazilian gate clamp shit.
Brazil gate.
Yeah. So we're gonna try to have him on here, and he can try
the first one to do that.
No, you nobody remembers that, Fade, and I'm getting sick and tired of you not doing cool stuff.
That's also true.
The world is. You've disappeared.
I'm like
you know how we talk about SQ?
I realized I never talking about SQ. I realized I never told you guys what I've got running in the daily. Fuck.
Yeah, you did.
Oh God.
Fuck.
Go ahead.
Well, so, you guys know what a transmission line enclosure is, right? Yeah.
For sure.
Yeah.
Yeah. So I've got my door cards are 53 hertz transmission lines.
Oh my God! Wait, have I seen that? I think I have seen that.
Yeah. So there's a video from a year ago on YouTube where they're in progress, but they're finished now. And so essentially left, right. My front doors have a single 6.5 inch, 250 watt RMS. Full range, essentially driver, and they're in a 53 hertz transmission line, and they sound fucking amazing. You don't even need a sub. It's insane,
bruh. That is amazing.
Yeah, props. Shout out to Harwood Acoustics in the UK for actually building those things. They're fucking incredible.
Shout out for you saying door card because
no, it's not.
What do you guys say?
Door panel.
They say panel.
Door panel. Yeah, no, we say panel as well.
No, panel is the metal part.
No, it's not.
The card is the plastic.
That's the effing door.
No, that's
what's the door? The whole encompassing everything?
Yeah. Let me just shut my door card. No, that's the whole door.
The door card is the plastic card bit that goes on.
Exactly. It's
door panel. Yeah, door panel. For sure.
No, the panel is the metal, inner and outer.
Panel could work as well.
Yeah, it does.
No, it doesn't. It really doesn't.
It works everywhere else in the world.
No,
that has the imperial system. I don't know what that is. All right, Mike was in for a second, but I don't know what happened. He got disconnected. But make sure y'all share. Mike Dio is coming in hot.
Yeah,
on Hall Effects.
Hot. He better be a
he's not.
He's clamp expert or he's getting kicked.
All right, I don't know what happened.
See that's the thing, right? So I've seen a lot of guys, and I've also seen this in myself in over the years in learning stuff. So at a certain point in time, you can feel like you have an idea and you have a really good idea as to how something works. And then 5 years later, when you're much wiser, you come back and you look at a video or some writing that you made on that subject and you go, oh, what the fuck? What was I chatting? This is completely wrong. So I am fully aware that a lot of the stuff that I've said over the last couple of years may not be entirely accurate, and speculations that I've made may not be true. Some of them might be, some of them might not be. So I am all for somebody with much more knowledge than me coming on and saying you're chatting shit, this is how it actually works. I love that, because then I fucking learn some stuff. That's how the world works. You learn from making mistakes, and you learn from thinking about, oh, how do I think this works, and then seeing how wrong you were, because you never get everything 100% right. So I would love for somebody to come on that knows a shit ton about this stuff, how the sensors work, etc., to maybe give some insight into how they work, and we can put our knowledge together and try and figure out what's going on here.
Boom! And there he is. The introduction, no needed.
Oh Lord, here we go.
Oh, can you hear me?
The young vote lord.
Say DC. Say DC, and I'll punch you in the face next time I see you.
Hello?
Yeah, we hear you.
We got you.
Okay,
stream,
hello.
bro.
Hello, bloke. How's it going? I'm sorry, I forgot your first name.
Sam.
Do you like to call me Sam? Okay, nice to meet you.
Nice to meet you too, buddy. Let's go, Mike.
Mike DiGuardo. You guys may know me.
No.
Owner of DiGuardo Engineering. I make custom voltmeters and voice coil temperature
You
sensors.
saying volt and the voice coil temperature sensor that was like once in the wild.
That's coming out. It's coming out. Just
I was cleaning my garage today, and I wrapped up like a V1, and I was like, "Oh, I'm gonna save this for posterity."
Yeah, but anyway, I just wanted to stop in, and well, I really wanted to just join in the beginning when you guys were just dropping knowledge, because I had so much things to say, and I could have contributed, but it's okay because I don't fix amps, and Sam over here is a expert amp repairer.
I don't fix amps either. I just sort of poke around and change
he just makes them work again.
Sam doesn't know like the running gag and like the American audio community. If you know me, and
No, he doesn't care about us.
don't ask me if I fix amps.
Mike like makes amps.
Anyway, what was I going to say?
Something about DC
offset.
offset.
Like the switching of like the full bridge. There's an issue with cross conduction, and the reason why the Brazilian amps are so like volt sensitive, and it's like they're glass basically, is the way full bridge switching works, and this can happen with if you have a single supply rail or a dual supply rail.
Yeah.
Which is another thing I forgot to add. So it's cost effective just to use one single power rail instead of two. That's why a lot of the Brazilian amp manufacturers go to full bridge. Because unlike a regular bipolar amp where you need both a positive and a negative voltage rail, one to push the subcone up, one to push the subcone down, a full bridge is basically hard switching back and forth. It's analogous to, because I remember I wanted to say this, it's analogous to taking a car battery, taking the leads, and just quickly flip-flopping them back and forth across subwoofer terminals. In essence, that's kind of what's going on. Now, it's doing this in solid state. So there's a thing called cross conduction, which is an issue with full bridge drive. This I have my mic over here. This happens with DC motor controllers and everything else. So there can be a point where there's so much current being pushed through the controller, pushed through your full bridge setup, that it would cross conduct. I wish I had a diagram up here. Maybe if one of you, Skip or Taylor, could pull up like a diagram of a full bridge.
I can. I've got OBS running. I can bring up a Chrome window if you like.
Okay, if you don't mind, but yeah. So there can be a slight instance if they're switching very close, both the push and the pull of the subwoofer, where they will overlap, and when it overlaps, that's a short circuit, and there ain't nothing stopping that. Boom.
Let me see if I can bring up a diagram here.
Dude, has anybody seen that Flat Earth documentary on Netflix?
I want to.
Okay, because the guy the star of that thing uses the same mic that Mike is using right now. So that I'm just saying.
I literally, this is like the third time I'm using this ever. I just because what happened was I installed the software-defined radio on my laptop, and for some reason it like messed with the sound drivers, and so now it doesn't detect my onboard mic. So I had to quickly, as I was joining the chat, plug this.
Just gotta throw that. I had to throw that out there. You believe in flat Earth, and everything you say is null and void.
What, me?
Yes. Anyway,
what
are we doing?
Whoa. I don't believe in flat. We landed on the damn moon.
Are you sure?
I don't believe we landed on the moon.
I'm just into like the crazy.
I don't know. I'm just saying. Everyone using that globe mic thinks the Earth is flat. I'm just saying.
So, Mr. Mike, my man. So we're talking about cross conduction. So that's relating to the output section.
Correct. Yes.
Yeah. So across the board, no matter what country you're in, no matter who's using the amplifier, no matter what setup the amplifier is in, the common theme surrounding the Brazilian amplifiers tends to be the power supply fails first, and the output section is generally always fine. That's why Taramps and Stetson have the there's a thing surrounding them. Oh, I catch fire, loads of smoke, and that's because when the power supply fails, obviously it shorts between plus 12 and ground. Therefore, just loads of smoke comes out until something goes open. So, if that's the issue in the output section, then what causes the power supplies to go down? My theory is that where these amplifiers are designed for more impulse current demand rather than continuous, and where they are designed for higher reactive loads as opposed to lower reactive loads like how America and Europe use them, the transformers on the power supplies aren't designed for the continuous current, and with heat and with how the MOSFETs heat up and with the continuous current, they saturate, causing a similar short circuit environment over the power supply MOSFETs, which causes them to fail. Would you say that that's viable? Or...
No, absolutely. That's exactly what happens when a core. So the transformer cores. Now, magnetics is a whole weird thing that would take me hours to explain, but I'm sure if you one night could write a script, you could probably do it in 30 minutes. I admire the way you actually. I always want to do like a presentation like you're doing, where you're explaining it in just basic terms that the common person could understand me. I could never be able to do that. So, but anyway, so yeah, the core is iron ferrite. Now there's a set, you can only pump so much current through it till the core saturates, and then when the core saturates, you can't pump any more current through. And in the eyes of the MOSFETs, that's a short circuit because, again, it's hard to explain inductance and EMF, but the coil itself, when it's switching, protects the MOSFET from going to a short circuit, because in the eyes of the MOSFET, it's seeing a reactive load. It's the reactance that protects the MOSFET from actually blowing up. And so when it saturates, it sees a short circuit, and that's when it goes. Also, I know we're running out of time here. So another thing that I heard in the community is the Taramps, I think. Yes. Not to switch again. Yeah, that's half bridge. So do we see a full bridge? Is there a diagram for full bridge? If you just type in full bridge, I don't like the diagrams where they cross the signals. That's if you just go to images, what's a good one? Full bridge. Scroll down a bit. Oh, here, there's one. All right, to your left. The one where it's got like blue, red. Oh, you missed it.
This one?
Yes, that one. Click that one. Yeah.
Okay.
Oh, is that I think that's a motor, so that's even better. Okay, so there can be a point. So the way that pretend that's a subwoofer, and you have your positive terminal and your negative terminal. So when you want to push the subwoofer cone up, you turn on the T1 MOSFET, and then you turn on the T4 MOSFET. And the T3 and the T2 MOSFETs, they're off. And if you want to push the subwoofer down, you do the opposite. So T3 MOSFET turns on, T2 MOSFET turns on, and if you follow it, the flow of current will flow down through T3 MOSFET, through the negative terminal, out the positive terminal, down through T2, and then right to ground.
Yeah.
So that's what's cool, because you're synthetically creating a negative rail.
Yeah.
In with respect to the sub. Now, when you're pushing a lot of current, there generates a lot of noise, and a lot of times the MOSFETs can't close quick enough, so you'll have a little bit of overlap. When that overlap occurs, it will be like T1 MOSFET is on, and then the T2 MOSFET's on. And if
so
you follow
the T1 just literally drains straight into T2, and there's a massive potential difference.
And then boom, and there's basically nothing stopping that. And what will happen is the MOSFETs, when you overcurrent a MOSFET, there's a thing called latch up, where they will stay on, and you will not be able to turn them off. Avalanche, runaway, it's called.
Is that failure, or is this? That's the failure.
That's failure.
Okay, so tell us how to cheat the TermLab, Mike.
Okay, like I said, TermLab uses an AC clamp. You hook up a secret 12-volt battery. Maybe it's through that little missing gas cap thing. I don't know. That missing gas cap thing raises some concerns. Maybe. Ooh, you want to know? I thought it's the other day. Maybe the gas cap sensor is tied in with some secret 12-volt battery hidden somewhere under there. Because I mean, do they take the subs out? Do they really take the subs out and look around inside there?
No.
Exactly. So they may have hidden a little 12-volt. All you need is a little 12-volt battery. And what that will do is, if you hook up, like I said, you hook up a 12-volt battery to a sub, what happens? Either boom, pops down.
Yeah.
So if they injected a negative DC offset in, so it forced one of the voice coils to be pushed down, that means the subwoofer is already halfway into its cycle. And so now you're just, boom, pushing it up with the rest of the amp. Think about it.
Dude, this is like some... Where's
Surely
my Alex Jones?
Hang on a minute. So while the subwoofer is playing, its resting position is no longer like at 0. If you're talking about like with no power connected, it's now sucked slightly in or pushed slightly out.
Yes.
Surely that would massively impact the score produced. Unless it's miles away from mechanical excursion, if you've got that much mechanical excursion left to play with, like say you're only using 30% of your mechanical limit, you can get away with sucking the cone in or pushing it out a certain degree, and
we
still
do know
having
that these
amount of
subs,
excursion available.
Yeah, these subs were special. T-Fade, what were they like? They were very special SPL.
Yeah, they were lightweight.
A lot
real
of
lightweight.
travel.
Well, maybe that's why they were. Maybe that's why they were launching cones.
They might even be biased slightly upwards or downwards.
Oh yeah, no, absolutely.
The 12 volts applied, it then rests at 0.
There's circuits cones on like 500 watts, so maybe they biased them the other way instead of sucking them in.
But this is going back to the thing where the Hall effect sensor. I'm just reading what it said off the TermLab website, that it's not Hall effect. It uses an AC clamp. AC clamps cannot detect DC, the presence of DC. They cannot. Hall effect sensors can.
Hang on a minute, wait. So the TermLab current sensor, you can't use that to clamp power, DC power coming into the amplifier.
Yes, correct. You can't. You can.
No.
That's
we need to change that. We need to change it.
I was under the impression that it's obviously got TermLab. You've also got SPL Lab. Obviously, they do the cheaper equivalents. Now, the SPL Lab make an offering of a unit that can clamp power, and they provide a current sensor that you can either use in AC or DC mode. So I assume that one is using Hall effect, because you can use it.
So there is a way to take an AC clamp and make it read DC, but it's very, very complex.
What are you talking about? I have an AC DC clamp. All I gotta do is do a little switch.
Yes, but that probably has. I have an AC/DC clamp too, but it probably uses some very complex chopper amplifier circuits. So here's the thing: if you put DC to an AC clamp, it will read it for a split second until the core, loses magnetism. Try it. I mean, if
I'm gonna try it till like tomorrow, literally.
I don't feel like any of the firmware refresh rates are quick enough to actually show it. Like the SPL Lab one's like half a second or a second refresh rate. Like,
yeah, and that's another thing. Like Hall effect clamps typically are slow, and they're not as accurate as an AC clamp. So I like. You have to go by the price. The price isn't
AC clamps are Hall effect. Like that's how they read the shit.
They aren't. Yeah.
They aren't R. How do you reckon it's reading AC current?
Because AC current can pass through. It's like a transformer. Like like a transformer, you have one winding around around an iron core, and then another winding, similar to a subwoofer voice coil. That can't pass DC. If you put DC on it for a second, it will read. You'll see one spike, and then it'll just die. You'll see a spike. That's it. It will not continuously read that DC current there.
All right, I think maybe we're getting.
I know it's very hard to explain.
It's the terminology that I don't want to get hung up on, but yeah, it's definitely the Hall effect that it's using.
What's using the Hall effect clamp?
The AC clamp is using the Hall effect to read current through the wire.
No? On the term lab, are you sure?
I mean, am I sure? I don't know.
No. If I'm just going by what it said on the Term Lab website. It's an AC clamp.
Mm-hmm.
The definition of AC clamp can only read AC. It cannot read DC. And further proof, doesn't the Term Lab have a frequency response?
I think 200. No, well, that's the sensor. No, that's
the dB sensor, isn't it?
Yeah. The pressure sensor can only read like 256 hertz or something.
But can it read 1 hertz? Just 1 hertz?
I don't know.
I'm
not sure.
That needs to be looked at. Well,
can we get somebody? Can we get somebody from Term Lab on the stream?
Yeah. So we're gonna have to have Wayne on here. So here's the latest contention that is that the carrier signal is being detected by the clamp, and it is saturating the clamp where it can't read the fundamental. So that, like, the output filtering, but Sam just told us there's no output filtering. So we're going to have to go back to the drawing board because that's a shit explanation.
Wait,
because that was the last
filtering. Like, there's no inductor on the output?
Sam's telling us that the sub is the output.
This is what I want to show you. So on this Tyramps here, okay, so this is HD 8000, right? So let's take a look at this. So this amplifier has some inductors on the output section. However, when you probe the positive and negative speaker terminal on these amplifiers, on the scope screen, you will see full rail-to-rail switching. Now, the positive and negative speaker terminals have the switch frequency in phase with one another. Therefore, the speaker sees zero potential difference. Therefore, it doesn't care about it. However, when you are connecting like testing equipment to either of these, so if you were to put your clamp meter on either the positive or negative, it will be seeing this rail-to-rail switch frequency. Moreover, when you use your oscilloscope, if I turn my scope on and I obviously, in order to see a sine wave from this amplifier, I will need to use the channel math. So I'll need to put a probe on channel 1, a probe on channel 2, positive speaker terminal, negative speaker terminal amplifier. I'll need to use channel math to subtract the two from each other so I don't see the rail-to-rail switching, and therefore leave me with the resulting sine wave. The resulting sine wave that I see on the screen is freaking made up of dot to dot. And so I feel like that's possibly the problem with how the clamp sensor is reading it. It's just tiny samples of the sine wave rather than a smooth sine wave. And possibly with the refresh rate of the firmware in the Term Lab, it's syncing up with whatever frequency you're playing, and therefore each time it takes a sample of the current, it's this kind of the same as what it was before, or roughly the same as what it was before, therefore giving an inaccurate reading. That's just my speculation.
Sorry to interrupt. The reason why you're seeing dots is because the math function on oscilloscopes is very processor intensive, and you're seeing Nyquist noise. So those dots, take the dots with a grain of salt, because that's not actually what it's really seeing. It's just that the oscilloscope can't process to that highest resolution. If you get here's the thing: if you get a differential probe, you could even make one. It's a simple circuit with a JFET and an external battery. You can make a differential probe, and you could actually see that a lot cleaner.
But why would you see Nyquist? Why are you going to see Nyquist on a full bridge and not?
It's his equipment. It's Nyquist noise from the oscilloscope is what he's seeing. Those little dots.
Why wouldn't you see it on a half bridge?
I'd love to show you it, and so we can confirm what we're seeing compared to what we see on.
You're only going to see Nyquist on digital, people. You're only going to see Nyquist.
There's that word again. What do you mean? What do you mean digital?
Oh my god.
Sample rate. Bing, 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 bing.
I'll have to get the differential probe from. Have to have it somewhere over there.
So okay, is there filtering? Is there not? Is it saturating the clamp? Is it not? What's going on, Mike? Tell us.
I don't think there's adequate. There's not enough filtering.
That's what we're saying. God damn it.
Well, yeah. But what I thought the theory was that the couple that supposedly cheated, which I think they really did, they modified the filter caps of the new Sound Digital amps, which has better filtering, and they converted it back to the old style filtering, which originally gave the TermLab problems in the first place.
Food for thought. He is an amp repair man or something.
Yes.
He can repair amps.
What, me?
No, the guy that
the boyfriend
cheated.
Oh yes, that's key thing. The guy who supposedly cheated is an amp repair guy.
So yeah,
think about it.
So that's the thing. I don't know how much simpler it is to explain some of these concepts.
You
know Occam's razor?
No, I'm saying like
Occam's razor. Once you eliminated all the possibilities, the simplest one left remaining is your answer.
Some of the comments in the chat are like, "Can y'all dumb this shit down?" Like, I don't know how much simpler.
No, I ain't dumbing shit down, yo.
Step your smarts up.
Young Volt Lord's got to talk.
Like signals come through. Like, okay. So basically, an amp has to break shit down, like a Class D amp tears his fucking signal up, turns it into ones and zeros, not ones and zeros, but it takes.
This is why I need a collab with Sam.
Takes little samples,
I was working on a video.
And then recreates the shit on the other side.
No, fax machine noises go in to the filter, and then music comes out.
It takes the battery and it switches polarity real fast and makes go up and down.
Yo, with a Class D amplifier, when you put an audio signal into it, right, it turns it into a telephone line. It sends it over to the Taramps database over in Brazil. They then process your audio and they then send it back as data over the internet. So your amplifier has fucking Wi-Fi, bro. That's why it fucks up the TermLab, because the Wi-Fi signals are passing through the sensor.
You're right, because it's using a non-FCC antenna.
Carrier pigeons.
All right, I got to get out of here, guys, but it's nice talking to you.
Yes, sir.
Thank you so much. Sorry if I was really annoying. I just really wanted to get in this chat and contribute, because you guys know I'm deep into, the amplifier design and the conspiracies and shit. But, anyway.
All day.
VCI 2, voice call temperature sensor. It's
Please, gimme.
I keep saying that. I will get it out before Half-Life 3 gets out. My word. Oh, also free 6.9. Free Daniel.
Yes, sir. Yes, sir. Free.
Peace out.
All right. I don't think people understand that there's a quote unquote carrier frequency for all this shit, and that's where all the interference and the saturation is coming from. Like, they don't understand that there's other shit going on. It's not just the fundamental frequencies that's being produced or carried through or whatever. I think that's where a lot of people are getting lost.
Yeah, there's basically on the internet, on the interwebs, there is a guide about how amplifiers work, and it's called
it's on your channel, I think.
Yeah, but no.
That's a great video, by the way. Y'all should check that shit out. It's awesome.
Loads of people, especially like old school, will have come across the website bcae1.com.
Hey,
local guy.
He's like down the road from
him. Yeah. He's like 45 minutes from me.
Yeah. So Perry Babin, So he runs that website. He created that website a long time ago, and it's a phenomenal website. But he also created an amplifier repair guide, which the majority of the basic community won't be aware of because it won't be interested in, and it costs money. However, within that guide, there is an interactive demonstration of how the fuck Class D works. How does it take the sine wave coming in, and how does it do some shit with it and turn it into a sine wave coming out? And it's really easy to understand. It's a visual representation. there's not really enough words. I can't like to try and explain how it works with words is just complicated. Like you just tune out, you lose interest. But there's a visual and a interactive demonstration where you can move the faders and you can see exactly how it turns a sine wave into pulses, then back into a sine wave again, efficiently in Class D operation. So, guys, if you've got $40 to spare, yeah, it's literally $40 or $50 to buy the amplifier repair guide. If you can spare that and you want to know how these things work just for your personal interest, and you want to support Perry as well, who has gone through some issues lately as well, then buy the amplifier repair guide and just spend a couple of weeks in your spare time reading through it. A lot of it will go over your head,
dude, and support that site. It's struggling right now.
Some of it will sink in, and the more you read it, the more you reread certain sections of it, you'll start to be like, holy crap, I get that. Like, that's why that happens, why that works. That's what actually that does. It might even spark your interest in amplifier repair. Car amplifier repair is not difficult. Once you understand the basics of how they work, they're all kind of much the same.
Don't tell people that.
Yeah, no, honestly, I'm all for getting more people into repairing their own shit, because
it needs to be smoke and mirrors
these days.
So it's all smoke and mirrors. I'm convinced.
But yeah, actually, you know what? I think that the Class D, demonstration isn't even part of the paid thing. I think it's even on the free site. I think it's even free. I might even try and link to that somewhere.
Dude, a BCAE1 is an amazing site, and he's struggling. He needs money to pay for keep the thing hosting. So y'all go donate.
Not enough people see it. Not enough people know about it. It's such a freaking great amount of information on there.
It's amazing.
What about parts for repairs? Like, do you? I mean, is it just straight any? You could buy from any common repair electronic shop? Or
yeah, like, so all of these manufacturers, they don't make their own parts. It's just a bunch of, like, you know, it's like Lego. If you want to buy a car made of Lego, then it's just Lego bricks. So you go to Lego and you buy the bricks to make the car, and you can build the car. So if these the parts in these amplifiers are just, they're just universal electronic components, voltage regulators, MOSFETs, drive chips. The only things in these amplifiers that are specific to brand are, like I mentioned earlier, the programmed chips, which if they do fail, then you will need to get them from the manufacturer, Taramps or Banda or whatever. But they don't fail very often. So most of the time you can repair this shit just with parts from Mouser or RS Components or whatever.
David Moore said, "Not Mouser."
Yeah, that's what the chat's screaming, Mouser.
Mouser.
It's just.
Hey, give me an ETA on that amp right there. We're gonna have to cut the hard line on you. Give us an
that's cool.
ETA.
That's cool. To be honest, this because these boards are so cold because they've been in the workshop and it's like really, really cold in the UK. This has taken a long time to solder. So honestly, I don't mind. I was just kind of doing this as the stream was going, just for effect anyway. So I'm 2 parts away from getting it possibly running. So it just depends how long this takes to desolder. But it's up to you. If you need to go, that's cool with me. I might release a video on this, on how these work at some other point anyway. So no drama. Ain't no tang.
Honestly, maybe you should make a video on it and like break it down.
Oh yeah, for sure.
And put maybe you need to go back and your drawing that you made, put that in there.
Yeah, I think it'd be interesting to some people to see how the Brazilians. I've been meaning to do a video for some time now on the misconceptions about the Brazilian amplifiers, full bridge, and how they work. They're not digital, they're not high voltage, etc., blah 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 blah. So that might be coming soon. But to be honest, I've been so busy with the repairs that I haven't done a lot of videos lately. So don't expect it anytime soon for sure.
I tell you, I don't have shit to do. I ain't got shit to do. I think Skip's mama is out there with the cable cutters about to cut the hard line.
I got threatened that she's gonna cut the entire hard line to the house if I'm not done by 8:00.
Wait, what's that?
She's walking outside with cable cutters right now.
The big ones.
Yeah. The big 2-hand ones to cut the line going to her.
Dude, Come on, man. It's like it's 2 a.m. here, and I'm just repairing an amplifier.
I can keep the stream going
chill,
and fade.
That's true.
Wants it to do. I don't care. But
look, hey, you talk to it. Well,
here we go. Okay, so the parts are removed. So let's see.
All right,
let's see whether I can get this.
I'm going to fill my cup.
Get this up and running or not. So, yeah, basically, in order to repair this amplifier, all I've got to do. So, if any of you guys are interested in what's going on with this piece of bullshit that I'm working on right now, so this is a Times HD 8K 8000 is the older HD line. Okay, so this amplifier came in with the problem that it turned on, the blue light came on, okay, but there was no audio, and it would go into protect after 10 seconds. Okay, so your first inkling would be to look at the output section. If the amplifier comes on, you would assume that the power supply section is okay because it's supplying power to the amplifier section to come on. Okay, so I was digging around in the output section. All the MOSFETs check out fine. The MOSFETs are the thing that are going to die first. If you have an amplifier that's blown, the MOSFETs are going to be the thing that have died. Okay, that's just because they're the things that are driving the speaker, right? So if the speaker develops a fault or if the amplifier develops a fault, the MOSFETs are going to die first. These guys all checked out fine. However, the amplifier came on and there was no switching. You know that big square wave that I talked about earlier? There was no big square waves on any of the output MOSFETs. There was just a blue light. There was nothing. There was nothing at all on the output section. And then it went into protect. So I was digging around for issues in the output section. However, it turns out that actually, in this case, the power supply section was to blame. And the reason that the output section wasn't coming on was because the PIC chip, the only bit of digitalness about this amplifier, when it focuses, was detecting that the output section wasn't getting enough current and a high enough voltage in order to operate because the power supply section was dead. Now, this amplifier, if we take a look on the back of this amplifier, Taramps amplifiers are very, very well known among us techs for blowing the traces. So these are the power supply FET traces, okay? So you can see here that there is a great big crack, a great big blown crack in this pad. This middle pad right here is where the 12 volts sits from the battery. And this power supply MOSFET is the thing that switches and generates power for the output section. So this has fused. See that freaking great big crack? That has fused the trace. So therefore, 12 volts is no longer getting to this MOSFET. And there was a whole bunch of these along the amplifier. There's another one on this one here. And there's another one over this side here. This one's gone bad as well. So basically, half of the power supply section wasn't working. There was enough of it left working for the amplifier to turn on, but not enough of it for the amplifier to start working properly. So once I figured that out, I've gone ahead and just for the live stream, just for purposes of the live stream, I've temporarily soldered in a couple of MOSFETs. So in this amplifier, there's 3 MOSFETs in parallel per bank on the transformer. So you only need 1 MOSFET per bank to get the amplifier up and running, just for idling purposes. So I've just thrown a spare MOSFET in this bank and this bank, and I've thrown a MOSFET in this bank over here that was dead, and this bank of 3 here was fine. It didn't have any problems. So I'm hoping that that's going to be enough to get the amplifier back up and running. And on the output section, I'm just replacing all the various parts that I removed while troubleshooting to try and figure out why this amp wouldn't turn on in the first place. So there's a couple of voltage regulators and stuff that I removed earlier. I'm just whacking back in now. So fingers crossed. I mean, I have no idea here. This is like all just like first time try. This is live shit. This isn't like fucking Art Attack. This is what I prepared earlier. This is
it's fantastic is what it is.
This is live shit. So if I put these parts back in, I should effectively be able to turn the amplifier on, and hopefully we'll be able to see some of those nasty square waves that trick the TermLab into thinking there's less power than there actually is. Hopefully, he says. I don't have massively high hopes because, you know, it's a Taramps and it's a repair, so it could do anything, but we'll see.
If you had to choose one Brazilian, you said Banda is your choice, right?
Yeah, definitely, all the way. Yeah, so Sound Digital have some really nice amplifiers. Don't get me wrong. Sound Digital are like very polished. Their amplifiers are very polished. You know, they're very nice. The transformers are good. The circuit designs are good. It's a nice thick PCB, etc. There's just not enough components for how us in the West want to run them. Whereas the Banda have gone all out, and yeah, they're really good. Boop. Last one. Let's try and turn it on and see what happens.
Skip, are you still there, or did you bone?
I think he fucked off, man.
I think he did. That's hilarious.
Yo, how many viewers have we?
I have no idea. I can't keep up with it when I'm just on the.
Yeah. So I've no idea. I think I covered everything. Right. So the first. So basically, that's all the parts now fitted. The first time I power it up, on the Taramps amplifiers, there's a little pad here that's labeled SD. See this?
Mm-hmm.
Shut down. So that is a little pad that you can apply solder to connect it like that, or you can brush the solder off to disconnect it, and that disables the output section. And that's used for troubleshooting and for testing. So the first time I turn this amplifier on, I'm going to leave it disconnected, which disables the output section, just because I want to make sure the power supply turns on okay.
Mm-hmm.
And then provided that turns on okay, I'm going to enable the shutdown, which will turn the output section on, and we should be able to see whether it's going to function or not. Whew. Wait, oh, hang on a minute. Let's turn that back on. There we go. So plus 12 volts going in here like that.
Moment of
Ground
truth.
going in like that. A remote going in like that. Actually, the remote has a wire coming out. Let's shove it over there like that. Yeah, I don't have massively high hopes. There's a very high chance on the power supply. So there's a couple of chips that look like this, right? These chips are the things that drive the power supply MOSFETs. These could be dead. I don't know because I didn't check them yet because I just pulled this up on the stream today. So if they work, then this is going to be good. If they don't work, then there's no point doing this.
We're all waiting.
So let's see what happens. Let's go. Yep, I'm just going to turn my scope on, and I'm just going to give you what screen should I give you? I'll give you this screen, but I will also give you I'll give you the power supply one. There we go. So you can see how much voltage and current's going in, and I'll give you the oscilloscope screen so you can see what I have on the scope.
Look at this. You're better than Skip. Maybe you need to host this show. The guy sucks.
Okay, let's grab my oscilloscope probe. Okay, so on the power supply MOSFETs, I should have, provided this is all connected, which it wasn't, because I suck. There we go. I should have 10 volts, which I do. So I haven't applied the remote yet. So yeah, that's cool. So to check the power supply is okay, I'm just going to make sure I've got my power supply voltage, which is 10.7 volts. I've got that on all of the power supply MOSFETs that are connected. Looking good so far. Okie dokie. Yep, that's cool. So now I've got a foot pedal under my desk for the remote. So I'm going to go ahead and hit the remote, and you'll see that as I press the foot pedal for the remote, it jumps up on the scope there, and the current increases on the power supply. So let's just see whether we have a nice looking square wave on the drive for this.
Have you ever seen NASCAR?
I like tiny bits, maybe.
You know, people watch that to see crashes, right? Can you make something blow up?
Can I make something blow up? No, the power supply is not quite happy. I don't have good drive. I actually have been thinking of doing a video for a while now, where I deliberately take a fully functional amplifier and I wire a self-destruct button into the amplifier, and we power it up, and I press the button, and it blows up into flames. That would be quite good fun, I think.
Yeah, that's what I do.
Yeah.
I'm really great at that. I'm real good at tearing shit up.
Yeah, man. I'm just going to quickly move which position this MOSFET's in, because there's one MOSFET that's got a bad gate resistor, and it will take 2 seconds just to quickly move it over to a different area. Come on, heat up, heat up, heat up, heat up. There we go. Take that over to this one. It's just so janky, but it will.
We're watching. We're watching.
It'll turn it on at least. This is super, super janky. Don't ever do this, guys.
Ever.
Amp repairs. Don't ever do this. So freaking janky. But yeah, bye-bye. Bye-bye. Come on. Fucking just trying to get this in the stream. Trying to get it on the stream.
We're definitely not stopping the stream until you make this thing blow up. So do your thing.
There's a high possibility that will happen, especially when I'm rushing shit like this. And
yes,
when we're rushing and it's a turrets, there's high possibility for fireworks. I shouldn't be showing this, man. This is gonna kill my reputation, man. What's he doing? What's he doing?
What is
he doing?
doing?
What's he doing, bro? Right, there we go. All right, let's see if we have decent drive on that one now. Let's give you the scope on this one as well. There we go. So I should now hopefully have okay looking drive on this one. Yeah, it looks about right. So when we first apply the remote, we just get a tiny little drive. You can see there's tiny little spikes that just shoot up. That's the amplifier's PIC chip. Like I mentioned earlier, that's the amplifier's PIC chip checking that the amp is functional, that there's no problems with the power supply. There we go. They're all getting drive. These ones are bumping up to about there. Yeah, that looks good. Okay, potentially we might have something that's going to work here. Okay, let's give you. What screen shall I give you? Scope only.
Give us the scope. There you go. Perfect.
Okay, there we go. So I'm going to have a look at the back of the power supply MOSFET. There we go. So you can see the little wave building. So this is the amplifier checking that it's okay. This is like a health check status.
Mm-hmm.
It's tiny little pulses that just checks the amplifier's okay. And every time that we apply the remote, if we look at the rail voltage, which is currently at 61 volts, every time I apply the remote, it's going to climb up very slowly. See this? It's climbing up very slowly, 72 volts. And it's going to go up and up, 75, 80, 85, etc. And the amplifier is only going to turn on when it gets to 200 volts. So that's pretty scary voltage.
That is.
I could die. that amount of voltage is definitely enough to kill me.
Yeah.
So
also that would
be seeing
that would make viewers would.
So let's keep going and let's let the amplifier try to power up. And we're going to go up. We got 129 volts, 178 volts. And what I want to do is just make sure the power supply is happy and the amplifier stays on. If it goes on to protect, then I know that there's a problem still in the power supply. 188 volts. So now currently there's so much voltage on the board that it's too much for my oscilloscope probe. So I'm just going to go ahead and swap probes. I'm going to go to my high voltage probe, which is this one. Let's plug that bad boy in. And then change the probe to times 100 and go to 200 volt, 100 volt. There we go. So now we are seeing 184. Let's keep going. There we go, 203. Let's knock the voltage down a little bit on the power supply to 10 point. Let's go with 10 volts. So yeah, 200 volts currently in the amplifier. Blue light. You can see a blue light there.
Yeah.
2 volts. Yeah. The fans have come on. You can probably hear that. So yeah, the power supply is working great. So the amplifier is going to come on. That's good news. Awesome stuff. So yeah, 200 volts in the amplifier. Not scary at all. If I touch that, that's going to freaking tickle a little bit.
Yeah.
All right. So now that I've confirmed the amplifier is actually functional and the power supply is looking good, I can go ahead and reconnect this shutdown pad, which will enable the output section of the amplifier and get it switching. Just before I do that, I'm going to check, make sure that there is pulse signal going in to this chip. So like I said earlier, this is the drive chip. This is an IRS2113S. And so I want to make sure that the amplifier is going to give that chip some nice, sexy pulses. So I'm going to go ahead and quickly Google IRS2113S, which is the model number of this chip. I'm going to look at the data sheet to make sure that, oh wait, I'm going to have to do it on Firefox. IRS2113S. And I'm just going to double check that we have good pulses going into the chip, because if we have good pulses going into the chip, then there's going to be good pulses going to the MOSFETs. This is an ancient computer that I'm using. Guys, oh, by the way, if any of you guys are computer geeks, you will be surprised to find out that I am currently streaming and running on an LG A775 setup with DDR2 RAM. Bruh! Freaking ancient stuff. Right, here we go. This is what I'm looking for. So, IRS2113S. Here we go. So, I'm looking for HIN, which is high input, and LIN, which is low input. So, I'm looking at pins 12 and 14. So, let's take a look at our board again and go for, which is it? This one. So pins 12 and 14, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's one of them. So let's go ahead and probe this pin. And I want to see some nice looking pulse waves on the screen. I might only see them. There we go. Let's check that out. Boop, boop.
I'm assuming that's a good thing.
Yeah, I'm just trying to get this to actually show up nicely on the screen because it's a little bit janky at the moment. It's not staying on the screen. Yeah, so those pulses are good news. The fact that we've got little squares like that, there we go. That's good news. That's good news. Yeah, that's very good news. So I just wanted to make sure that they were definitely present, and the fact that they're present is good news. So that gives me good news, and I can go ahead and short out this SD. But before I attach some solder to the SD, there is still 200 volts in these freaking capacitors. So we're going to take a load resistor and short out these rectifiers over here to get rid of the voltage in the capacitors, so I don't like kill myself. So let's just see where the voltage is in these capacitors. It's on this side. There's 134 volts, and ground is over here. So I'm going to take one wire and put one wire on 134 volts, and the other wire is going to go on ground. Hopefully that shorted out those caps, and now we have nothing on here. Yeah, look at that. There's nothing on there now, so that's good. No more voltage.
Being all safe and shit.
No more voltage. Cool. So now let's turn my soldering iron back on and let's solder the shutdown back together. There we go. Shutdown pad is back together, so the amplifier should come on. This is the point where it could blow up.
I like this point. There you go. Take a drink.
Let's have some more wine. Oh, by the way, guys, if you just started the stream, this is not tea. This is Sainsbury's Pinot Grigio white wine.
Yes, my people.
Yeah, boy. Yeah, boy. Yeah. So let's go ahead and fire this bad boy up. So we emptied the caps. So we got to build the row voltage again from 0. Let's give you the scope screen.
I don't know if you're following the chat, but I got to tell you, everyone is rooting for it to blow up.
Fuck's sake, guys, come on, man! This is a customer repair.
No, look, we'll take donations. We'll take donations. Get old boy a new amp. We just want to see some fire.
Fucking hell. 150 volts. We're just currently building the rails back up again from 0. Yeah. 174.
Nobody sets gains.
188.
Yep, just get out of there. Wine in a box. Don't hate.
Okay, so this is the moment of truth. So what I'm going to do now is I'm going to put my oscilloscope probe on the MOSFET that should have a square wave on it if the amplifier is working correctly. What the hell? Current amplifier vibratory boy. That's not correct. Wait, let me get rid of that. That's bollocks. That's an old live stream, that is. So yeah, provided there's a square wave on this MOSFET, it works. If there isn't, then there's going to be some fire.
Yes.
So fire. Let's give you this screen.
Yes, I'm hoping for fire.
Yeah. I'm not hoping for fire because that'll be very bad.
Just saying. Just saying.
I've got 5 amps going in. Okay. Come on, baby. Ooh! Oh yeah, baby! Oh,
almost like you know what you're doing.
Oh
almost
yeah!
Like you know what you're doing.
I see a square wave, motherfucker. Okay, let's see that again. Let's see that beautiful square wave. Ooh!
What?
Woo-hoo-hoo!
Look at that slew rate. I can't even hardly stand it.
Blue lights on, square wave on the outputs. That's a wrap, baby.
Oh
yeah, that's a wrap. That is a repair. Yes. All right. Now, anyway, now that's fixed, that wasn't what I wanted to show you. What I wanted to show you was how the oscilloscope views the sine wave from these amplifiers. So what I need to do is I need to go ahead and turn on my frequency generator, and I'm gonna shove like a 50 hertz through here or something. Yeah, let's what have we got? Fucking 30 hertz. Let's crank that up a little bit. 40 hertz. This is meant to be going up. Why are you going back down to 33 for 24? What the fuck? Right, hang on a minute. This is a massively dodgy, cheap as fuck frequency generator. There you go, 48, that'll do. So 48 hertz. So what I want to go ahead and do now is take the RCA from this, plug it into the amplifier, and get a sine wave playing on the amplifier, and so you guys can see exactly what the scope sees when this is playing. So I think, from memory, I think this one is gain. Here we go. Let's have a look at the heatsink here, so we can see which knob does what. So that one's level, so that one needs to be up a little bit. So about there, maybe. This one's high pass, and this one's low pass. Let's turn that up a little bit. There we go. Okay. So yeah, in order to show this to you guys, I'm going to need to do 2 oscilloscope probes. So let's remove my high voltage probe, because we know that the amplifier works now, so we don't need that one anymore. And I need to plug back in my low voltage probe. Where the fuck did I put my low voltage probe? Is it on the floor? Ah, there it is. No, that's not it. Did anybody see? Ah, found it. Never mind. Got it. Found it. Found it. There we go. Plug that back into the scope. There we go. Turn right. So I'm going to give you the scope screen so you can see what the fuck I'm doing. So what I'm doing now is I'm turning both of the. Whoa, stay still. I'm turning both channels on, channel 1 and 2. I'm setting them both to, I don't know what, fucking 10 volts, right? And I'm going to change the time divide to 5 milliseconds and reject high frequency. That will allow us to see audio sine wave on the outputs. Okay. So what I need to do now is take probe number 1. Probe number 1 needs to go on one of these like this, and probe number 2 needs to go on the other one. How I'm going to secure those on there, I don't know yet.
You can't just probe the speaker output. Oh, you can't.
Yeah,
not to show us.
So it's
Not
a
to show
full
us.
bridge.
Right.
It's a full bridge. So there is a sine wave on both positive and negative speaker terminals. So I need to probe both of them in order to show you what the speaker sees. Okay,
Tenfold.
So plug these bad boys in here like this. I mean, I'm just going to kind of rest them on here because we're ghetto as fuck. You know, like that, and maybe like that. There we go. Right. So what you guys are about to see, what the subwoofer sees when the Torrance amplifier is turned on. Okay. So yeah, this is times 10 times 10. Yep. So let's go scope only. So I'm probably going to have to turn this to 50-50 in order to show you guys. So yeah, this is what essentially the clamp meter and the subwoofer is seeing when this amplifier is turned on. Let's just get this amplifier turned on first, because I'm sure there's some voltage missing from the amplifier. Right, so I'm sure you can see a fuck ton of noise. So there's there's a 48 hertz sine wave playing right now. Okay. If I remove the sine wave, so there's no signal playing whatsoever, okay, you can see what the output sees. So it's kind of similar. So even with no audio playing, there's this great big square wave. Yeah, you see that great big square wave?
Yeah.
It goes so high that it goes off the scope screen. Maybe I can bring the voltage down a little bit on the power supply. So it turns off. There we go. Let's try that again. I'm trying to go low enough voltage that it shows up on the screen, because this is a very, very high voltage amplifier because it's a 2-ohm version. So the there we go. So that is what is currently on both speaker terminals at all times. So the subwoofer doesn't see this. Because there's the same thing on both speaker terminals, the subwoofer doesn't see any difference. The subwoofer only sees the difference between channel 1, which is this, and channel 2, which is this. So fortunately, because I have a fancy ass motherfucking oscilloscope, I can go ahead and do channel math. And I can show you guys what the subwoofer sees by, I think it's subtracting the channels, I think it is.
Which is nothing.
It's not quite nothing. It's still something.
It should be nothing.
Yeah, but it's not quite nothing because these are janky amplifiers. Right, there we go. So this right here is what the subwoofer sees. It sees a little line here.
Oh, shit.
Yeah? So the subwoofer is seeing this, which it isn't much. Oh, okay, it's quite a bit, but it's very, 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 very fast. So this is a very, very, very high frequency. Okay, so the subwoofer is seeing a little line like this. What is it? 100 and hang on a minute. I can't tell you because the voltage is too high. It's 10 microseconds. So that's probably about 250 kilohertz. So the subwoofer will never play this frequency, but it still sees it, and the voice coil will still be filtering it, therefore heating up. So if we go back to, so this is the audio range, okay? 5 milliseconds. Here we go. So we're going to filter high frequency. So if I now plug in the RCAs to apply a 48 hertz sine wave, then we shall see what the subwoofer sees. And I'm just going to go ahead to display, turn vectors off. Here we go. So this is the kind of sine wave that the subwoofer sees on a Taramps amplifier. See this? So it's kind of like made up of dots. You see that?
Yeah.
So I think that is why these meters have such a problem with reading this, because it's kind of made up of dots like this.
That's like a lot of extra information.
Yeah, it's a fuck ton of noise. There's a whole bunch of switching noise and all sorts of bullshit going on. So that's what the subwoofer sees.
Is that exclusive to Taramps, or is that like on all the full bridges that you see?
That is exclusive to any amplifier that runs in full bridge and doesn't have full filtering of the Class E switch wave. The Bandit amplifiers, the Viking up to the 10K, has full filtering of the sine wave, so you don't get that stuff. You don't get that noise. Above 10K on the Bandit, you do get that. The Sound Digital, the older ones, didn't use to filter it, but some of the newer ones do, depending on what power you go for.
Is it just caps? How are they filtering this stuff?
Inductors. So, okay, let me try and find... okay, here we go. Just down by the bench here, I've got.
Are those
this,
DD headphones?
Yeah, absolutely. Yeah, digital designs.
You nut hugger.
Yeah, man. So this is a JL Audio 1000/1. So this amplifier is a Class D amplifier, so it works in a similar way, but it's half bridge. So because it's half bridge, it can't give the subwoofer that big square wave, because the subwoofer will see that as a potential difference to the ground. So therefore, it has this inductor. Now, this inductor filters that high frequency noise and only allows the pure sine wave to pass to the subwoofer coil. As a result of that, this inductor gets quite hot because it is doing work. In order to filter, it's doing work, and therefore it gets hot and it eats into the amplifier's efficiency rating. That's one of the reasons these Taramps are so highly efficient, is because they don't have any filtering losses. So yeah, the half bridge amplifiers and some full bridge amplifiers that have filtering will take a slight hit in efficiency to filter the output sine wave in order to give a cleaner audio wave to the voice coil. The voice coil doesn't really care. The voice coil in itself is an inductor, and it will not care too much about the high frequency noise. A little bit more heat will be applied to the coil as a result of the noise being there, but not enough for it to be dangerous or a problem in a car audio application, really. So, fair play to Taramps. They haven't really done anything wrong here. This isn't an incorrect way to drive a speaker, but it's just a kind of janky kind of way of doing it. It's not going to cause any problems the way that they've designed it and the way that they've done it, but it's not like the textbook clean, perfect way of giving a subwoofer giving a speaker.
Yeah. And to be fair, we're not trying to shit on Taramps in this whole thing. It just so happens you had one on your bench. You're trying to show us the full bridge.
No, I have mad respect for Taramps and for all these Brazilian companies for actually using modern drive circuit technology, modern MOSFETs, and creating amplifiers with them.
Yeah.
Like, fuck Korea and their 20-year-old designs, man. Get them out of the shop.
Damn.
Like, I have mad respect for Brazil and the Brazilian companies for giving this a go, designing a circuit from scratch. Right, this circuit is solely Taramps. Right, you will not find this exact circuit in any other amplifier. Fair play. I have respect for that. It's your own circuit. Same goes for Alpine. Same goes for Rockford Fosgate. Same goes for JL Audio. Same goes for all these brands that employ a amplifier circuit design technician to design them a unique circuit for that one brand, and that's their own thing. Fair play. Mad respect there. all these other brands that have the same fucking circuit in them as every other brand from the same factory. Yeah, it's a reliable enough circuit. It's an old circuit. It's a bugs ironed out circuit. It will do the power with a loss of efficiency, whatever. I don't have as much respect for that as I do for these guys giving this a go and designing a circuit from scratch. That is the way forward, man. Like, design something from scratch with modern components, modern technology, modern drive circuits, and you might, that's progression. That's the way forward. Like, I like Sundown, I like Digital Designs, I like Ground Zero for some things that they do. But those kind of brands, they are not amplifier design brands. They are not known for their amplifier design. They are known for, like, Sundown are known for their subwoofer. Like, you can't get a Sundown subwoofer from any other brand that is exactly the same as a Sundown subwoofer. You can't go to another brand and get a Digital Designs 9.5 series. You can't go to another brand and get, well, you might be able, but there are certain brands that make subwoofers that are only their subwoofers. There are certain brands that make amplifiers that are only their amplifiers. JL Audio, you can't go to another brand and get a JL Audio amplifier board because they don't do it. It's a JL Audio board. However, you can go to, like, if you take a Sundown SAZ and a Ground Zero and a Digital Designs and like a bunch of other brands amplifiers, and you take them apart, take the casing away, and just look at the circuits, they're the exact same circuit with a couple more FETs on one or a couple more caps on the other. It's the exact same thing.
To be fair, I don't think you can. I don't think anybody has any of Sundown's current stuff. I mean, maybe in the beginning, but I don't think these days anyone can afford to do it. But listen, I could literally sit here and bullshit with you all night, but I have got to get downstairs and feed the family and whatnot. But I appreciate you coming on. Honestly, I learned a lot. I hope the chat learned a lot, and we appreciate you sharing your knowledge. And if you want to expound on this, make a video, tell us all about it. And I know a lot of people here appreciate the fact that you're on board with Full Bridge and saying that that's the way forward, because honestly, that's we all want more efficient and more power and less components and smaller amps. So I'm all about it.
Yeah, I think it's definitely the future, and that's where the attention should be turned. Definitely.
Awesome, man. Well, we appreciate you. We appreciate you coming on, brother, and maybe we'll have you back. And next time there's an amplifier controversy.
Good to be on the stream, man. I hope you guys enjoyed, and I hope I didn't chat too much shit.
No.
And catch you guys next time.
All right, buddy. Appreciate you.